Hello everybody, let's do a little review on simplifying radicals. Okay, first thing I want to discuss is our list of perfect squares. Okay, so 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. So all these numbers down in the right hand column are our perfect squares up to 144. Okay, so let's try something like the square root of 12. I'm going to show you two ways to do this, all right, and you pick which way works best for you. So we want to look down this column here to see any numbers that go into 12, and when you want to get it, the highest number that goes into 12. So the highest number that goes into 12 is 4. So the square root of 12 is the square root of 4 times the square root of 3, with one of these numbers being a perfect square. Okay, so we're going to take the square root of 4, which is 2. Square root of 3 we can't do, so we have 2 square root of 3. Now another way we're doing it in class is we were doing factor trees. Okay, so we're going to get the prime factorization of 12. And there are all the numbers that multiply and equal 12. Put all these numbers underneath the square root symbol. Okay, we cross off 2 of a kind, move that outside, okay, and we leave that underneath. So we can do this for anything. How about square root of 18? So we look down this column for the biggest number that goes into 18. We see that it's 9. So the square root of 18 is the square root of 9 times 2. Now it can be written like this, or it can be written like this. If I'm going to write it like this, I'm going to then separate it, okay, with one of these being a perfect square. Square root of 9 is 3. Square root of 2, can't do. Square root of 2, leave it like that. When you see the square root of 18, we're not looking to get decimals here, okay? So we got the square root of 32. All right, so we're going to look down here for the biggest perfect square that goes into 32. Biggest perfect square that goes into 32 is 16. 2 times. Square root of 16 is 4. 4 root 2. Now, I don't want to do the square root of 32 and say 4 times 8. 4 is in that column right up here. Square root of 4 is 2. 2 root 8. These are equivalent. They're equal to each other. However, this can be broken down further. Okay, square root of 8 is square root of 4 times square root of 2. This 2 comes down. Square root of 4 is 2. Square root of 2 stays here. So we get 4 root 2. Let's try another one. Square root of 75. So we look down this column for the biggest number that goes into square root of 75. And we say 25. How many times? 3 times. Square root of 25 is 5. 5 root 3. Square root of 14. There are no numbers in this column that go into 14, so the square root of 14 simplified is the square root of 14. That cannot be simplified any further. If I wanted to show you what I mean by a factor tree, 14 breaks down into 2 and 7. And there are no pairs to move outside, so this just stays as square root of 14. Now let's try the square root of 80. Let's do the factor tree. 2 and 40, 2 and 20, 2 and 10, 2 and 5. So I take all these numbers and I put them underneath the radical symbol, and you cross off 2 at a time. Cross off 2 2's, put 1 outside. Cross off another pair of 2's, put another one outside. That's going to be multiplication outside. Keep the 5 underneath. 4 root 5. So that's by factor tree. Another way you could have done it is gone through this list and find out what number goes into 80 evenly. 4 does, but 16 does also. 16 times root 5. Square root of 16 is 4. 4 root 5. How about square root of 288? You go down this list, look for the biggest perfect square that goes into 288. You find out it's 144. Square root of 144 is 12. The answer is 12 root 2. What about if you come up with a number like 578? And we go down this list. You know this list keeps on going, so you might have to try a bigger number. You might have to keep going. Okay? And the square root of 289 is 17 root 2. Now how about if we have 3 root 2 and we want that squared? Let's try this without a calculator. This is going to be 3 root 2 times 3 root 2. We're going to put the numbers that are outside the radicals together, numbers inside the radicals together, and now you're allowed to multiply. So 3 times 3 is 9. Root 2 times root 2 is root 4. So it's 9 times the square root of 4, which is 9 times 2. So our final answer is 18. So hit pause and see if you can get 4 root 5 squared. Hit pause and come back. Okay, I'm glad you're back. So I'm just going to follow the same steps. I'm going to get the numbers that are outside together, inside together. This becomes 16 root 25. 16 times 5, which is 80. Okay, 7 root 2 squared. Hit pause, see what you come up with. All right, let's see. Okay, you're also learning what numbers you're allowed to multiply. You're allowed to multiply outside times outside, inside times inside. So this becomes 49 root 4, which is 49 times 2, which is 98. Okay, how about if we have root 6 squared? All right, that's root 6 times root 6, which is root 36, which is just 6. Okay, root 11 squared. Root 11 times root 11, which is square root of, multiply them together, 121, which is a perfect square, which is just 11. Okay, try these two, see what you come up with. Let's see. 5 root 7 squared, and let's see, let's make it 7 root 5 squared. See how you do. Okay, hit pause, then come back, see what you got. All right, glad you're back. So our first one here, we got 175. What you get for the second one there? I got 245. All right, I hope you found this review lesson informative and helpful, and I'll see you on the next video.